to fit exponential models to a dataset. Lesson 9.4. What are exponential models? Exponential models are used to fit a set of data that shows growth or decay, so they're similar to linear regressions or exponential regressions. We use the equation y equals a times b to the x power to describe them. Exponential models never really reach zero, no matter how close they get to the x-axis. Examining the equation. The exponential equation, as previously mentioned, is y equals a times b to the power of x. The a in the equation is equal to y when x is 0, or when you're at your starting value. The b value is your growth factor, and your x value refers to the time that has passed. How to fit a set of data to a graph. To fit a set of data to a graph, you must gather all the data given. This is usually given in a table, as seen in the example. You must then determine the patterns and what the values represent. In this example, let's pretend that x represents hours and our y values represent bacteria present in a Petri dish. So as every hour passes, there are twice as many bacteria in the Petri dish. Our starting a value would be 2, and our b value is the growth, which is also 2 because it's going up twice as much every hour that passes. Moving on to the next part, finding the equation to find a point in the table. So we're putting everything together. Step 1, finding your values. So let's use an example from the book. In this scenario, a drug is administered to a patient, and the table is being used to track the amount of drug in milligrams that are present in the body in correlation to the time that has passed since it was administered. What we can gather right off the bat is our A value, which is 1000 because it's the first value that we see in the table. But what we don't know is our B value because in this table we can't really make a clear understanding of the connection between these numbers because they all kind of look like random numbers. Step 2. Making sense of the equation and subbing in your points. So clearly we don't know too much about our equation except that our A value is 1000. Our equation is now y equals 1000 times b to the power of x. So we can choose a random point from our table and put it into our equation. I chose the point 2085. If we plug in these points into our equation, it should now look like 85, which is our y value, equals 1000, our a value, times b, which we don't know yet, to the power of 20. Step 4. Solving for b to get our equation. So you basically want to solve for b the way that you would solve for any x in an algebraic equation. So we have subbed in 85 for our y value and 20 where our x was, and then again we still have 1000 as our a value. So you want to solve this the way that you would solve any equation. You would clearly divide out the 1000 because that's the easiest to get to that side, and then you would want to find the 20th root of 0.085, or you could just put it to the power of 1 over 20, and your final answer should be that b equals 0.884. So now that you know what your b is, you can put everything into the equation and you get y equals 1000 times 0.884, which is our b value, to the power of x. So I know that this probably seems like a lot, and that it's a lot to remember. So the easiest way for me to remember anything is to put it to the tune of a song. So I wrote out all the steps and then I put them into sequential order to the tune of Jingle Bells, and I think that that is the easiest way to remember how to solve for B and how to get all of the values that you need to plug into your equation. So sing along with me. Take a set of numbers and find out where it starts. Plug it in for A and pick a random point. Plug in X, plug in Y to find out what's your B. Then all you gotta do is solve algebraically. Yay! Thank you. That's it. That wasn't so hard, and I hope that this helps, and happy studying, guys.